Hello students, welcome to the subject of Mathematics 3 for all my mechanical engineering students, myself Dr. Ankit Acharya, and in today's lecture we discuss about for non-exact exact differential equation case 3 and case 4. Okay, so if the differential equation, here you can see that case 3, if the differential equation is of the form this form f1 xy, that means function of xy into y, okay, into there is a function of xy and in form of multiplication there is y, and same way some another function of xy into x dy, okay, and then integrating factor just 1 upon mx minus ny, okay. So integrating factor, that is 1 upon m into x minus n into y, okay. Of course, m into x minus n into y not equal to 0, then only we can take integrating factor, and after multiplying with integrating factor the equation become exact and can be solved using the method of exact differential equation. Clear? So make sure that your differential equation is this type of differential equation, okay. Function of xy into y dx plus some another function of xy into x dy, okay. Let's take one example. Here you can see that this is function of xy, x square y square plus 2, okay. This is a constant, so we can take x raised to 0 into y raised to 0 and plus 2 minus x square y square, okay, into x dy, that is equal to 0. So there is some another function of xy, okay, 2, that means we can take x raised to 0, y raised to 0, so that is also function of xy and x square y square. So in each and every term the degree of x and y both must be same, okay. Here you can see that this is my f1 xy. F1 xy is what? Okay, f1 xy is x square y square plus 2, and f2 xy, f2 xy is what? Sorry, f2 xy, okay, f2 xy, that is 2 minus x square y square. Clear? 2 minus x square y square. So f1 xy and f2 xy, x square y square plus 2 and 2 minus x square y square. So m is equal to x square y cube, okay. M is equal to what? X square, because this y now we multiply with both the terms. So here x square y cube plus 2y and x multiply with this term, so 2x minus x cube y square. So clearly we can check that the differential equation is not exact, because suppose we find del m by del y, okay, del m by del y is what? X square as it is, so 3y square, so x square into 3y square, okay, 3y square and plus 2, okay, and del m by del x, del m by del x, okay, so that is 2 minus 3x square y square. Clear? So del m by del y and del m by del x both are not equal, so clearly the given differential equation is not exact, okay. So now we can apply case 3, because this is function of f1 xy into y dx plus f2 xy into x dy. So integrating factor is what? 1 upon m into x minus n into y. So 1 upon what is your m? M is x square y cube plus 2y, and we have to multiply with x. So x cube, what is m into x? M into x, that is x cube y cube, okay, plus 2xy, and n into y, okay. So this is my n, so that is 2xy minus x cube y cube, and m into x minus n into y, so m into x minus n into y. So clearly this x cube y cube minus x cube y cube, so we will get 2x cube y cube, okay, and 2xy minus 2xy, that will be cancelled. So 1 upon 2x cube y cube, that is your integrating factor, okay. Clearly I just write each and every step so you can easily understand. So now this is my integrating factor, 1 upon 2x cube y cube. Now multiplying this integrating factor with the differential equation, so 1 upon 2x cube y cube, we multiply with m, so m is x square y square plus 2y, x square y cube plus 2y, that is what, into 1 upon 2x cube y cube into dx plus n is what? 2x minus x cube y cube, so 2x minus x cube y cube, okay, 1 upon 2x cube y cube dy, that is equal to 0. So finally we will get this equation 1 by 2 1 upon x plus 2 upon x cube y square dx plus 1 by 2 2 upon x square y cube minus 1 upon y dy, okay, that is equal to 0. So m1 is equal to 1 by 2 1 upon x plus 2 upon x cube y cube, okay, x cube y square, clear? And n1 is equal to what? 2 upon x square y cube minus 1 upon x, okay. And now here you can check that del m1 by del y and del n1 by del x both are equal, okay, because this is your m1, okay, m1 is what? 1 by 2 1 upon x, okay, 1 by 2 1 upon x plus 2 upon x cube y square, okay. So when we find differentiation with respect to y, so differentiation of 1 upon x, that is 0, with respect to y, differentiation of 1 upon y square, that is minus 2 upon y cube. So finally we will get 2 upon x cube y cube, and del n1 by del x is minus 2 upon x cube y cube. So del m1 by del y, that is equal to del n1 by del x. The equation is exact, hence the general solution is integration 1 by 2 1 upon x plus 2 upon x cube y square dx, integration 1 by 2 minus 1 upon y dy, that is equal to c. So 1 by 2 integration of 1 upon x, that is log x, and this is minus 1 upon x square y square minus 1 by 2 log y, that is equal to c log x, okay. So 1 by 2 log x, so log x into log y, okay. Finally we will get 1 by 2 log x minus 1 upon x square y square and minus 1 by 2 log y, okay. So log x into log y minus 1 upon x square y square, that is equal to c. So log x upon y, okay, log x upon y minus 1 upon x square y square, that is equal to c. Finally we will get this solution, okay. Now let's discuss about case 4. If the differential equation is m dx plus n dy equal to 0 and this is non-exact, so integrating factor we can take 1 upon mx plus ny, okay, providing mx plus ny not equal to 0. Homogeneous equation in x and y, so degree of each term is same, okay. Homogeneous equation in x and y, that means whatever the degree of x, the same degree of y in each and every term, so we can say homogeneous equation, okay. So in that case integrating factor we can take 1 upon mx, okay, this is my integrating factor 1 upon mx plus ny, okay, and must make sure that mx plus ny not equal to 0, okay, and your differential equation is homogeneous in x and y. So let's take one example. So x raised to 4 plus y raised to 4, so you can see that this is homogeneous because degree of x is 4, degree of y is 4 here, and minus x y cube. So the total degree of x and y, the degree of x is 1, degree of y is 3. So the n equal to 4, okay. This equation is, we can say that homogeneous with degree n equal to 4, okay, because each and every term the degree is 4. And clearly this is not exact because m equal to x raised to 4 plus y raised to 4, so del m by del y, that is 4y cube, okay, n is equal to what? Minus x y cube, so del n by del x, that is minus y cube, so del n by del x and del m by del y, these two are not equal, so not exact, so we have to make exact. So what integrating factor is what? Integrating factor is 1 upon m into x plus n into y, okay. In previous case 3 our integrating factor is m into x minus n into y in denominator, so 1 upon mx minus ny, here 1 upon mx plus ny, okay. So that's why this equal to 1 upon, what is your m? M is x raised to 4 plus y raised to 4 multiply with x, so x raised to 5 plus x y raised to 4 and plus, okay, n into y, so n into y is what? Minus okay, minus x y raised to 4, okay. So minus x y raised to 4, so plus x y raised to 4 minus x y raised to 4, that will be cancelled out, so 1 upon x raised to 5, this is my integrating factor, 1 upon x raised to 5, clear. So now we have to multiply 1 upon x raised to 5 in this equation, okay, the given equation. So clearly we can multiply, when we multiply integrating factor is 1 upon x raised to 5, So multiply on both the sides, 1 upon x raised to 5 into x raised to 4 plus y raised to 4 dx minus 1 upon x raised to 5 into xy cube dy equal to 0. So that's why this is x raised to 4 upon x raised to 5. So 1 upon x plus y raised to 4 upon x raised to 5, okay, dx, and here 1 upon x raised to 5 and here x. So minus y cube upon x raised to 4 dy, that is equal to 0. Okay, so this is your m, and so del m1, so del m1 by del x, now you can check, that is del m1 by del y. Okay, so one differentiation of 1 upon x, that is 0, differentiation of y raised to 4, that is 4y cube upon x raised to 5, and del n1 by del x, okay, that is equal to minus 3, okay, del n1 by del x, so that is minus 4 x raised to minus 5 into y cube. So finally you will get 4y cube upon x raised to 5. So both are same clearly. Okay, you can check that now your new differential equation. See, multiplying differential equation by integrating factor. So you will get this your m1. This is your m1. Del m1 by del y and del n1 by del x. Both are same. So you can find the general solution, okay, using the method integration m1 dx. So integration m1, that means integration 1 upon x plus y raised to 4 upon x raised to 5 dx. Okay, and now n1, in n1 we have x. Okay, we have, there is a term of x, so we cannot take n1. So integration 0 dy, that is equal to c. So that's why it is equal to, okay, integration of 1 upon x, that is log x, okay, I can write log x, integration of 1 upon x raised to 5. So that is x raised to minus 5, so x raised to minus 4 upon minus 4. So minus 1 by 4, okay, x raised to 4, y raised to 4 as it is, that is equal to c. So this is my final answer. Here you can see that log x minus x raised to 4, okay, y raised to 4 upon 4 x raised to 4, that is equal to c. Okay, so in today's session we discuss about for non-exact differential equation case 3 and case 4. Okay, so there are 4 cases for non-exact differential equation, and using integrating factor we can make it exact differential equation, and we can easily solve, we can easily find out the general solution for that new differential equation. Okay, so thank you.